Hi there, welcome back. So today I'm going to show you how to insert a breeze into HEC-RAS model. So we are working on this model, right? This is called breeze scour model. So at the very end of this tutorial series, we'll see how to calculate the total scour around the breeze pier. So we'll do that in the next part. I'm hoping that. So today I'm going to show you how to insert that breeze because we are already done with the model simulation, right? We already I simulated different scenarios. We added the steady flow condition. We interpolated the cross sections as well. So first, before inserting the breeze, I'm gonna delete the interpolated sections we have here. So how can I do that? If you open that geometry editor here and then go to tools and then cross section interpolation there, and within a reach, because we interpolated within a reach, and then if you delete interpolated sections, then it will delete everything for you. Then see, everything is gone because these are the 20 sections we inserted from Excel file. So you know by this time how to create the geometry from survey data. If you have assigned a survey company, then they will survey this data from you and they will generate this data either in Excel format or any other format. So we have to do that in the past two tutorial, right? The part 1 and part 2, we already demonstrated that one. So today I'm gonna just show you the location where our bridge section is, right? So where is your bridge section? So I'm gonna show you the map again. See, that is the plan for the survey cross section here. So we already have idea about that one in the first part of this tutorial. You can check that if you didn't. So here it is, right? We have total 20 sections and we have this because the number is coming from upstream. So we put it there 1, 2, 3, but in the plan, they started this section number from here at the very upstream, and the upstream sections are 1, 2, 3. So we have total 17 section at the very upstream, right? From the breeze. So the number is decreasing toward the downstream. So we have number 1 at the very downstream, and we have 3 sections at the downstream of the breeze. So the breeze will be located in between section number 4 and section number 3 there. Okay, section number 4 and section number 3. So in between these two sections, we'll insert our breeze here. Okay, or you can insert in between any location you want. I'll show you how to do that. So that's the trick. But for this case, it will be in between these two sections, section number 3 and section number 4, because the section number 4, it is the upstream section, and section number 3, it's the downstream section. We can do that, and we have a distance in between these two sections. It is 500 meter, right? Meter or half a kilometer. So how can we do that? Let's analyze our section number 4 and section number 3. What is, right, the value of the section? So we can even select directly from there. Section number 4, you can see the extent, right? So we have the width of the river as 200 meter. Here you can see the value is 200 meter. And if you select section number 3, see it is even 200, right? 200. So that's the thing we have here. So what we can do, we can select 200 and we can insert the breeze. So how can you do that? We have the options right here. We can select, if you click on cross section, it will open the cross sectional view, and if you open this breeze or culvert, it will open that one. So that's the options, right? That is the option for today. I'll work on that one. And before going to do that, right, we already have idea about how to analyze the flood event and how to find the value for 100 year, 50 year, and so on and so forth. We already have the data, and if you know, right, what is the navigation route, and based on that navigation route, we have to fix the number of span or the distance between the two piers, and what will be the vertical clearance of the breeze. You have to know that. If you know your navigation class, then you'll have, right, this is from the book or the reference or different manuals. You can find that for your country, for your location, right? So I'm going to select this one as class 2, and then based on that one, I'll fix the vertical clearance as well as the horizontal clearance as well. So how can I do that? I can open, okay, I can open the breeze or culvert. If you click there, see it's selecting the entire reach of the river, and then you have to select where you want to put the breeze. And when you are opening that breeze or culvert editor, then it is giving us these options, the breeze options, right? The breeze properties, we can do that. But at first we have to go to options, and then we have to create a new breeze, means add a breeze or a culvert. So what I'm going to do, I'm going to give, see it is asking, right, enter a new river station for the new breeze or culvert in reach, that the river reach we have. So I'm going to give the number as 3.5 because it is in between 4 and 5. So it will be 3.5. That's the number rule. And then see, it's going to give you that 2 section, right? I just mentioned you. That is the upstream section, the section number 4, and that is the downstream section, section number 3. So we can even insert our breeze. So what is the maximum elevation here? You can see, right? That is the section, but our breeze will be right away from it. So it will be higher than that, a lot higher than that, because we know our highest high water level, right? We know that. What is the value of our highest high water level or our 100-year water level? We can check that. Steady flow data. We can check it, right? We know that by this time. So which one is that? So here it is. This is 6.5. So if you know that is 6.5, so we have to add that value, and after adding that value, it is giving us, I'll show that one, what is the value, 15.62. And that is the highest chord of the breeze, because we have a breeze, right, that has a height, it has a low chord and high chord. In between these two chord, the breeze is not that big because the river width is like 200 meter and the navigation route is class 2. So that's why I'm selecting that way. I'm not going to give you the value, I'm going to give you only the maximum value and the minimum value, because this value will be varying for, right, from country to country. So that's why you have to fix that one. So that will be the maximum value. We know the maximum water level, and based on that we have to add them up, right? The water level, maximum water level, and after that we have to add the vertical clearance. Then we'll get our low chord. And if you just add that height of the breeze or the deck of the breeze, then usually the deck of a breeze, it will be 2.5 meter. Then you will get the high chord. So we'll fix that way. So here it is. We already have the cross section, and then we'll add our pier, number of pier. That is another option. At the same time, if you know the vertical clearance, you'll know the horizontal span as well. So what will be the maximum length of a span for navigation purpose, right? If you have a big ship, if the river width is very big, then there will be, right, if the class is 1, then there will be a big ship that will pass under this breeze. So you have to make that clearance both in vertical direction and in horizontal, right? So that's that. So for this case, I'll make the span as 50 meter or 150 feet, more than that. So I'm gonna fix it that way. So here it is. We have the bridge section. We have to add the deck or roadway. If you click on that, so it is asking to enter the values. If I enter, because a breeze is not only a deck, right, or the column or the beam, it is not like that. It has two different structure called abutment as well, right, on two different sides of the breeze. So at first we have to give this as the coordinate. So after creating that breeze, I'll explain that, then you'll understand that, because I have to show this. So at the very beginning here, right, here we have the code, because this is the width of the river, so we have to insert that breeze that way, right? So at the very beginning we have the 0 coordinate, right, because that is the length from the left side to left bank of the river. We already know what is left bank and what is right bank, because this model HEC-RAS, it only takes input from the left bank. So the very first value, it is 0, right? We're starting from the bank, because you can see that is the bank, the red mark. And what will be the high chord? Because we know the highest high water level 6.5, and we're gonna add, right, the clearance, vertical clearance. If we add that, it will be 12 point. It will be 13.12, right? It will be 13.12, and then if I add 2.5, it will be 15.62. So that's that. And then we are here, we added that, and then we are moving from 0 to 4 because I'm giving the abutment thickness, it is 4 meter. Okay, that is the support that will connect the breeze with the road. That is the connection. So it will be 4, and then the high chord, it will be same. Okay, 15.62. Basically this high chord, this will be same. So it matters only the low chord, and if it is 4 again, it will be 15.62. So this is how we have to provide the high chord in the high chord column and the low chord in the low chord column. And this is only for the upstream side of the breeze. Then we have the downstream part of the breeze. So we can even copy these values from upstream to downstream. We can do that. It is not a problem. So here it is. Okay. And the low chord at the very beginning, right here, the low chord, it will be 0 at the very beginning. And then I'm going to give it is -6, so that is just below the ground, because we have -2, so that we can cover the river. And then the low chord is 13.12. I told you that. And if you add your vertical clearance with your highest high water level, like 100, right, year flood level, so we are adding that vertical clearance with that 100 year of flood level, then we are getting this low chord. And then we're adding the height of the breeze, means height of the deck of the breeze, as 2.5 meter. Then we are getting the top of the breeze, high chord. So this is how we are getting these values. And then what we have to do, we have to cover, right? We have to cover this width of the river. So how can we do that? Even we can add another value as 50 meter. Okay, we can do that. The next value will be like 50, and then another will be like 100, and then the next one will be like 150. We can do that. This is pretty simple. And what we have to do, we have to enter these values. We have to copy and we have to paste. We have to paste it. We have to paste it, right? So that's why. And again, same thing for this one. We have to paste it. We have to paste it. We have to paste it. Okay. And you'll see what it will show you. If I click OK, see, it's gonna show you that part of the breeze only, right? And it's gonna cover up to this one. So we have to cover from this part to that part, and we'll have a thickness of the breeze. So this is what we're gonna do here. Okay, so if I just open it again, the editor we're gonna do here, so we have the values, and if you select there, copy to downstream, so then it will be filled up. Okay, copy to downstream, upstream to downstream, the same value we copied, right? And we have to cover everything. And then what you have to do, so here we can see the breeze, right? The breeze, that type will be the weir coefficient. We know that coefficient usually will have to use like 2.5, and what will be the distance between the upstream and the downstream section, like it's 50, and right, and then it is kind of the width of the, right, the width of the road or width of the breeze. Usually what we use here, it like 5 meter. Okay, 5 meter, because the road is not that highway or international road, so that's why we're giving this one. So that's the thing. Embankment, so here we have to give 2, and the downstream we can put it as 0, and then the maximum submergence we can put it as 95. We are not gonna use 98%. And weir crest, the shape will be broad crested, right? If you have idea about the crest, we can use that one, broad crested. So that will solve the problem. And then we are done with the upstream part. See, if I click here, you'll see the change. See, you can see the upstream section and downstream section of the breeze, but we are not done yet, because this line should be here, right? On the other end of the bank, on the other bank, right bank of the river. So here it is. We have to even finish this up, and then what I can do, I can even continue with that. Like we are done with 150, then we have like 225. We can even use 225, and let's see if we can cover it or not. If it is okay, then we can go with that one as well. So what I'm gonna do, it will be the same value we have here, upstream, and then here it will be like, okay, 225, or we can give it as 224 or 226. Okay, 226, because the next value I'm gonna use here 230, because the abutment will be 4, and then it will be 15.62. It's this value I just started at the very beginning, because I'm gonna make this part asymmetrical on the other side of that one, right? So here it will be -6, and then it will be 0, right? So that's that. And if I just copy to downstream, we're finished with that. And you can see we have the same thing here, because you can see that the breeze, and if I move it that way, you can see the breeze. Can you see that? Yeah, but we have to modify that one. See, still it is not done, so it is not even covering here. Okay, so it should be the same. We have to cover this one as well. So that's why it is showing sloping abutment. So we have to fix the coordinate. It is not even done up to this part. It is not even showing. So how can we fix it? So if you know the plot, right? See, you can see at the very bottom on the other side, you can see that we have this sloping thing, but here it is different than what we have here. Okay, so what we have to do here, we have to fix that, right? We have to just continue this line all the way to there, and then it will be this way. So we are gonna check it, right? The maximum value here we have, it is 200 here, right? But for the downstream case, if it is same, say it's gonna continue. So what we have to do, we have to continue this value. What is the value? The low chord, right? The low chord, it shouldn't be -6 here. It should continue all the way to that 220. Okay, let me just open that and you will see what I'm gonna talking about here. So that low chord, we have to continue, right? So it is, see, we're gonna fix it up to 150. So instead of doing that, this should be 220. This should be 222, and let's see, 220 even, okay, 222, that's okay, and this is also okay. So I'm gonna copy and I'm gonna paste it there, and then this should be 226, okay, and this should be 230, and then it will be like, I'm gonna copy this one and I'm gonna paste it there. This should be -6, and this should be 0, and then it will give you more accuracy. It's gonna do that, but we can't see that one. This is how we have to fix the right bank, because the maximum value here we have, it is 200, right? If it is 200, so we have to fix that. This is the calculation we have to do. The left bank is pretty clear, because we have to show the symmetry, right? So that's why I need to reduce the number, because it is 200 here. So other than doing that, I think I should do it as this value should be 190. This should be 190. Okay, 196, 192. Okay, 192, and then if I just make it 200, and this should be 196, and that should be 200. Okay, if I put it this way, and let's see what is gonna get. See, now it's pretty nice, right? So we have the breeze, the upstream section and the downstream section. Now it's pretty nice and clear. You can see that's that. So this is the breeze. We have this abutment and we have this structure. You can see that we have some kind of a structure there, and we can put it as sloping abutment. You can put the slope here as well, but for this case I'm not going to do that. Even you can make the slope this way, the slope I made previously, right, to protect the bank of the river, or to protect the road, right? Because we are giving this 4-meter abutment, so that's enough for this type of river. This river is not that mighty river, so we can go with that one, whatever we have. So now what we have to do, we have to insert, right, that piers, right, at 50-meter interval, because we are gonna give the horizontal clearance as 50 meters. So that is our next goal. So we have already inserted our breeze, and we can save the breeze data because it is already there, and I can even close it. I have the geometry. You can see we have the breeze. You can see the breeze section, right? If you click on there, we have the breeze, and I can save the geometry. Save the geometry as, this is not interpolated geometry anymore. I don't need that. So breeze geometry, okay? I'm gonna give the name as bridge geometry. So we have the bridge there. So what we have to do, we have the bridge, but the next step is to insert that piers. So I'll give you the dimension of the pier, and I'm gonna show you how to insert that one. So here we have the bridge deck and roadway. We're done with that, and next click on the pier. Okay, if you click there, so first it is gonna give you only number 1. So what will be the center line? At first, if the bridge is basically 50-meter interval, right? The pier should be at 50-meter, or you can even reduce to 30-meter, whatever it is. I'm gonna show first at 50-meter. So from this clearance, right, from the 0, if you consider the chain is or the distance from 0, and if you wanna, because this is the concrete, right? So the clearance should be from here to the center line of the pier. So it will be 54, and the downstream side it will be 54, right? And you have to provide the pier that will cover from the bottom to the top of the bridge that will support. So what it will be there, and width of the pier you have to give it is 1.5 meter. And then what will be the elevation, the bottom elevation? It will be -10. I'm intentionally giving that so that it will go inside that right bottom of or this artwork. It will be there, and then if I put it again 1.5, and I'm gonna go up to this low chord, okay, 13.12, then it will toss that, and we can even copy to downstream the same thing, and we're done with this one. So I'm showing that one. See, we have the first pier, and you can even copy the pier, right? And you can even replace that one as well. So I'm gonna repeat that process, right? I'll also only change these values, the location, because that is the coordinate of the location. I'll add 50 with this one, and then okay, I'm copying that, and it will give you another number. So what will be the next value of the pier, right? 54 plus 50, it will give you 104. Okay, 104. And then if I click OK, it's gonna give you another one. And what will be the next one? If I just click again and copy, it's gonna give us 3. And then we have to measure everything from there, right? So next it will be like 154, and it will be 154. If I click OK, it's gonna give us this one, 3 pier we have, right? 3 pier, because our total width of the river is 200 meter. So we have this one, that's it. If you wanna even reduce the number, if you wanna insert more, you can do that, okay? So this is how we can insert. And okay, I'm gonna show you even if we insert more piers, that is also possible. But for this case, we can run the model, not a problem. So we have this one, okay? So because our boundary condition or flow rate, everything is done, we're just done with our bridge. We inserted that one, and now we can go for the model simulation. I'm gonna save it because I modified that one. Okay, save the geometry, and then I have to create that run condition again. Go to run, because we don't need to change our boundary condition. We are running this model for a steady one, and I also demonstrated how to run, right, and on a steady flow. You can check that video as well. It is already there, but that video was not for this location, it was for another one, because I'll show the sediment model for that on a steady flow for that location as well, because I have the data for that location as well. And for this case, after this tutorial, I'll show you how to calculate the bridge pier. We just inserted the bridge, and we'll calculate the bridge scour, right? We'll calculate the scour around the bridge pier. That is called hydraulic calculation. We'll do that. So that is that one, hydraulic design function. We'll use that, and we'll use the output from this model simulation for that specific cross section, and then I'll show you how to do that in the next part of this tutorial, and that will be the final part. Okay, so here it is, steady flow analysis, and then I have to create a new run, a bridge geometry. We're gonna select that one, and we have the 100-year flood, right? And then if I save the plan, it's gonna ask it is gonna be breeze. Okay, breeze. It is breeze, and okay, breeze 100 here, 100 here. Okay, yeah. We're just gonna design the breeze for 100 here, and let's see, we have to provide breeze. Okay, breeze 01, first run for the breeze. So we have that flow distribution location is already there. We already selected that one. Everything looks okay. So if I hit compute, then it's gonna calculate everything for us, including the breeze. Let me click that. If everything is okay, definitely, because we checked right previously, and still the model is checking, and within 4 seconds it's done. Let me open the results. Okay, if I click there, it is gonna give us the section. Okay, and it's gonna give us the plan for 3 different conditions. See, when it is 25 years flood, you can see the water surface is there. That is the water surface. And if you're gonna see the water surface for 50 years, it is gonna give you this elevation. And what is gonna happen if it is for 100 years, right? That is the elevation you have, and these are the basically energy level. So that is the water surface for 100 years. So if there is a flood that has the magnitude of 100, and you have to pass any like ship or any vehicle, water vehicle, so you have to provide this clearance, right? So, and the vertical clearance, because that may be this much high. So see, the coordinate will be like from this one, that is almost 7, okay, almost like 8, but 7.5, and then in between this 15.6, 13.62. So that is the low chord. So the height of the vehicle should be in between this one. And if your flood is 25 years, then you'll get more room to pass your vehicle. So that's the main reason to design any breeze, right? That is the main reason to design a breeze, and we have to be able to calculate the scour. When there will be this type of flood, there will be some scouring, right? So this breeze may not be stable there, so you have to do some piling work. So if it is necessary to do, so you have to check what will be the scour. Then you have to go beyond that depth, and you have to provide some treatment, right, like piling or other treatment as well. And at the same time, we'll calculate the abatement scour as well. Maybe there will be some, right, slip circle failure of the bank of the river, so you have to protect that as well. So in order to do that, we have to analyze if there is any necessity to do that. So that's that, pretty simple, right? So we can insert any breeze simply, but the main thing is to calculate the scour. We'll calculate the scour, and for calculating the scour, like here around the breeze pier, we need to know the sediment distribution here. So in order to do that, we have to collect the sediment. That's why I'm going to show you this series of tutorial here, because I have the data, because we already assigned the survey company to collect sediment sample, and I did this sediment analysis in the laboratory. Then I'll show the values of the distribution using CV analysis. And but for this case, the sediment was so fine, it was clay, it was passing through 200 number 200 sieve, and then we basically followed hydrometer analysis to get the gradation of this bed material. And we also did the same thing for bank material as well, and I'll show that. So in order to calculate that scouring kind of thing, we need to have the sediment information for this bed of the river and the bank of the river. So we have both data. I'll show you how to do that. So I'm not going to show you right now. So you can see the velocity distribution. So now you can consider, okay, on the right side of the breeze, you'll have more velocity, right? 2.9 meter per second here. So your concern should be here, because the breeze is located kind of at the bend of a river, right? So at the middle, we don't have that much velocity, it is less. But on the on two sides of the river, we have more velocity. So your point of concern should be here. And if you, this is the upstream part of the breeze, and if you go to downstream part of the breeze, you can see because the right side is kind of dry, however the middle is so deep that we have to, right, calculate, scour, and there may be some dangerous issues. We have to be able to find that out. So we'll do this. So that's why you have to check both upstream part and the downstream part as well, right? So that is the deck of the breeze. It is 2.5 meter, and that is called low chord, and that is called high chord, and that is the navigation route displays for 50 years of return period, 100 year of return period, or it may be 25 years return period. So this is how we can run a model and you can analyze. And this time if I show the perspective plot or the profile, you can see we have the breeze, right? You can see that the profile, you can see right here we have the breeze, and that is the right top of the breeze, and water is not reaching the top. We have the clearance. When you will have ship that is right, move from left to right or right to left, and you'll see that okay, it's gonna pass the breeze pretty easily. If you have 100-year flood, you'll have the water level there, right? And you can see the velocity, it is right increasing from subcritical. Maybe there will be, of course it will be subcritical as well, but you have to check what is flowing that way. And if I want to show the perspective plot, this one you can see the breeze is located there. Now it's pretty simple, right? You can see that, you can see the breeze here. Now we inserted the breeze, you can see that. So that is the option we have, and we can use that. See, we have the breeze, what is coming from upstream to downstream, and our breeze is there. So that is the road we can see. So this is how we can insert a breeze, and we can run the model, and then we can analyze our data. And in the next tutorial I'll extract the velocity, and I'll extract every information necessary. I'll show you how to do that, and I'll also show you how to use our sediment distribution of the gradation curve to calculate the breeze scour and to calculate the total scour, and which equation is necessary to use for calculating the scour as well. So you can try by yourself because you already have the data for this location, so that you can finish off and let me know if you have any query or a question, then we can solve it, no problem. So thank you very much for watching and stay safe. See you in the next tutorial. Bye.